Now, I want to start by giving you an overview of what this particular section is about. Module 2 explored variables by looking at their distributions. And distributions show patterns and trends, but eventually we want to be able to make decisions that are based upon these distributions. And we do this by depending on probability, which is the cornerstone of decision making in statistics. We look at what we observe, and then we assign a certain probability to the idea that what we observe in a sample is going to generalize to a larger population. And so probability is based on theory or observation. We're going to learn a couple of rules about probability. The first is the converse rule, and this occurs to the probability of event not occurring. So if the probability of rain is 0.6, the probability of no rain is 0.4. So this is very, very easy. A probability is bounded by an upward value of 1.0. So the probability can never be greater than 1 or less than 0. So if I know that the probability of any event is a certain value, then the probability of that event not happening is 1 minus the probability of that value. So this is very intuitive. I also can talk about the addition rule, and this is the probability that one of several outcomes is going to happen. And this is predicated upon the idea that there aren't going to be simultaneous outcomes. So if I want to know the probability of event A or event B, I define that as the probability of event A happening plus the probability of point B. So an example of the addition rule from the criminal justice literature is that if a defendant has a 0.52 probability of being convicted as charged, or a 0.26 probability of being convicted of a lesser charge, and a 0.22 chance of being found not guilty, the probability of a conviction, which covers those first two categories, is simply 0.52 plus 0.26 is equal to 0.78. So this looks at the probability of conviction as charged or conviction of a lesser charge. So all I have to do is add those up together, and I get a conjoint probability that a defendant will be convicted. I can also have a multiplication rule in which I'm looking for a combination of independent outcomes. So I might want to know what's the likelihood or the probability of A and B occurring, in which case this is a multiplicative function of the probability of event A plus multiplied by the probability of event B. So as an example, also from the criminal justice literature, if I know that a police department has a 60% clearance rate for homicides, I might want to know what the probability is that any two are going to be cleared, in which case the probability of 1 is 60% and the probability of 2 is 60%. So if I multiply those together, 0.6 times 0.6, I get a 0.36 probability that any two homicides in a given department are going to clear.